So let me take you back to 2016 when it was the US election between Clinton and Trump. Of course, now we are in the future, so we know the outcome of this. But what I have here are the pre-election predictions, right? And the reason why I brought this up is because we've been looking at distributions. And really the power of these distributions are in its applications. But what I will say is that because this is like an introduction to this concept, we won't dive too deep into the required mathematics here, right? But the idea is that we can use these distributions to make predictions about populations, right? And we've been looking at the Bernoulli distribution, we're looking at the binomial distribution, and now we're going to look at using the concept of a sample to make predictions about larger things that's related to those distributions, right? So for example, if you have a population and you want to get some information about it, a very common one is like voting results, right? What might you do? Well, if you wanted a true accurate representation, you'd ask everybody. What do we call that when we ask everybody a question? Like a big survey, basically, right? You might, your census, right? Because every 4 years, I believe, Australia will run a census, right? But if you remember the first time they tried to run this census online, there were a lot of issues, right? The website crashed, people were worried about data breaches and all this kind of thing, right? So it's very expensive, costly, and time consuming to actually try and run these censuses, right? I don't know if that's plural, but censi? I don't know. Anyway, so the idea is, instead of taking a census, we can take a sample. Now, mathematically, there are ways to show that if you can take enough of a sample, then you should get results that are accurate to the genuine results. And this is what they came up with, right? What do you guys notice when you look at this picture? This is the pre-polling, right?
We do a poll in our class, who's the biggest pain?
Me. No. And then Harry, yeah. So you could do a census with this group very easily, right? It's only, what, 8 people or whatever, right? But when you're looking at the whole of America, like, this is the pre-polling map. Blue represents Clinton, the Democratic Party. I don't even know my American politics. And then red is Republicans, right? Someone will correct me if I'm wrong.
How did Trump win? Look how far he was behind.
Say that again?
Like, he was so far behind.
He was so far behind.
He won eventually.
Right.
He got less votes, but he got more states or something like that.
Well, so this is the thing, I was just doing a bit of a deep dive into American politics. It's, yeah, a bit of a Wikipedia run. But the first thing that I noticed was when you look at this, the area of red just seems more. Even though Trump, as a number, has 216 and Clinton has 322 in his prediction. Sorry?
Only 216 people voted.
So these are what we call electoral college votes. So the idea is that your individual vote isn't a part of the majority that votes your president candidate in, okay? And there's a really good reason why that's constructed in such a way. But basically, what's actually important is this number here. So if you look at this number, can you see how each state has a number? That's basically how many votes that they get to vote their choice of president, right? So you can see some numbers are higher than others. For example, Texas down here is 38, whereas North Dakota here is 3, right? So you may be thinking, oh, that seems a bit unfair. Why is Texas getting 38 of these votes and North Dakota is only getting 3? Well, if you think about the other option is every individual voter counts towards voting in the president. In reality, the population of Texas is more than 30 times bigger than North Dakota. So can you see how they've tried to balance that out a little bit? Even though the population is 30 times bigger, how many times bigger is the number of their college vote, electoral college vote? It's only about like 12, right? A bit over 12 times, yeah? So it's kind of like a balancing system there. So that's the first thing that jumped out to me. Like the red seems like there's more surface area, but actually the important number is not the red, like the kind of area that it takes up, but actually the number here. So you see California is like 55, Florida is like 29, and they're like smaller than Texas, but they have similar votes. Sorry? It's like beaches and Florida Keys, I don't know, a lot of stuff. Right? So when they did this pre-polling, right, there were some issues obviously because this is not how it turned out. It was not 322 to 216 as predicted. In fact, here are the actual results. 279 to 228 were the actual results there, right? So that's the electoral college vote. These are the ones that count. Typically, you need 270 to win the majority, I believe, right, in these electoral college votes. And I want to talk a bit about mathematically why this error might have occurred, right? Let's talk a bit about sampling. When you take a sample of people, right, you can get, mathematically, we have devised a way that we can select enough of these people so that we can get a true representation or the population proportion, the actual number required, okay? So a certain characteristic that may be voting for Trump, right? See, the other issue though in this is that when we have voting, another issue can kind of come up. The other issue is, well, think about voting, right? It's not just a numbers thing. Like obviously, if you pick a small number of people, you're going to get some issues. In fact, here's an example of how you might want to select people, right? So you can see that the margin of error for a smaller sample size is quite high. It's like 10%, right? But then as you increase the number of sample sizes, then the margin of error becomes smaller and smaller and smaller, right? But in terms of a voting thing, it's not just the number of people you select. What other issue can arise, do you reckon? Like not just how many people. Obviously, if you pick more people, it should be more accurate, right? Is everyone going to vote? That's one issue. Like in America, voting is actually not compulsory. So the people that you ask, are they actually going to vote? Yeah, donkey votes, that kind of thing, right? It's also related to actually like have a look at the areas, right? Think about where you pick people from. Why might that matter? Like where I pick these people from. Why might that be a consideration to make?
Because maybe someone in Texas is like, they were like Trump, and then like another country like, oh,
Right,
no,
right.
Clinton.
Well, so like the idea is that there are these sort of stronghold states, right? So like typically you have these Republican, Democratic states. They often go between them, right? They might change from year on year. But if you're asking a lot of people from Texas, right, then your numbers are going to be skewed towards Trump voting. Or if you ask a lot of people from California or Florida, then you're going to have a lot of Clinton voters, right? So there are some systematic errors that also can arise from this, not just from a mathematical perspective, yeah? But the other thing to notice is that as you take more and more of these samples, what do you notice this shape kind of looks like? What kind of distribution have we learned about? It's a normal one, right? So that's something else that's going to be a key factor. That as you take more and more of these samples, it's going to tend towards what we call the normal distribution. And it means we can reuse a lot of the same properties that a normal distribution has. Like what have we been using? What kind of calculations have you been doing with the normal distribution in advanced and extension 1 and... Sorry?
Density.
The density function, you've been finding the area under the curve. Sometimes you have to use z-scores, right? So all of these things here, the mean, variance, all that kind of stuff that you've been doing, that's the kind of questions they're going to apply for this situation here, okay? So that's just a bit about what's going on here. Let's jot down some notes for you, all right?